Imagine this. You're dropped into a maze at midnight. No flashlight, no GPS, no way out. Total darkness. How would you find your way? You'd probably panic, right? But for dolphins, darkness isn't a problem. It's just another day at the office. These animals glide through pitch-black waters as if they're playing with a built-in radar. But here's the real question. How does a dolphin's sonar not only compete with, but actually outsmart some of our most advanced technology? And what secrets does this natural sonar hold that even submarines and scientists are still struggling to copy? Stick around, because once you hear how dolphins do it, you'll never look at the ocean or your GPS the same way again. So what exactly is happening inside a dolphin's head that makes them the masters of the sea? Welcome to WildFact Lab, where we break down the wildest animal abilities with real science, and maybe a few wild analogies along the way. Think about it. Humans built GPS satellites, submarines, and sonar systems to conquer the oceans. But dolphins? They've been doing it effortlessly for millions of years. No wires, no batteries, no software updates, just pure biology. And here's the kicker. What if I told you their sonar isn't just a way to find fish, but a full-blown navigation system so advanced, it can reveal size, shape, even the texture of objects underwater? So today, we're diving deep. We'll uncover what echolocation really is, break down how dolphins turn sound into vision, compare their skills to our best sonar tech, and explore the mind-blowing things they can do that machines simply can't. The question is, are dolphins just animals, or are they carrying around the ocean's most advanced navigation system nature ever designed? So, let's start with the basics. What exactly is echolocation? Imagine shouting inside a cave. You hear your own voice bounce back, right? The echo tells you how big the cave is, maybe even hints at where the walls are. Now, what if you could turn that echo into a crystal clear picture? That's exactly what dolphins do, except they're not yelling in caves. They're firing off rapid clicks underwater at frequencies so high we can't even hear them. But why clicks? Because sound travels 4 times faster in water than in air, which means echoes come back almost instantly. Dolphins send out a click, the sound waves hit a fish, a rock, or even another dolphin, and the echoes return with details packed inside them. Here's the wild part. Dolphins can produce up to 150,000 clicks per second. That's so fast, it makes a machine gun sound like slow motion. And while we hear nothing but silence, the dolphin's brain is busy building a 3D map of its surroundings in real time. So the real question is, how do dolphins actually process those echoes? Where in their body does this high-tech sonar system live? The answer might surprise you. So where does this sonar magic actually happen inside a dolphin? Believe it or not, the secret isn't in the eyes, it's in the head. Right here, in a rounded organ called the melon. But what is the melon? Think of it like a biological speaker, a living lens made of fat tissue that focuses sound waves into a powerful beam. Dolphins send their clicks through the melon, directing sound with pinpoint accuracy. But once the echoes bounce back, how do they catch them? Not with the ears like we do. Instead, the sound travels through the lower jawbone, which is hollow and packed with fat that acts like an acoustic funnel. It's like having a built-in microphone wired straight into the inner ear. And here's the mind blower. Those echoes aren't just background noise. Dolphins can tell if an object is hollow or solid, whether it's smooth or rough, even if it's made of metal or plastic. Imagine walking into a room and instantly knowing every object's shape, size, and material without turning on the lights. So the big question now is, if dolphins are this advanced, how do they stack up against the technology humans have built? Can a billion-dollar submarine really compete with a dolphin cruising the waves? So here's the showdown we've all been waiting for. Dolphins versus human technology. Who wins? At first glance, you'd think the answer is obvious. We've got submarines, satellites, and million-dollar sonar systems. How could a dolphin possibly beat that? Well, let's break it down. First, frequency. Human sonar usually runs between 1 and 50 kilohertz. Sounds impressive, right? But dolphins can crank it up to a staggering 150 kilohertz, 3 times higher. That means finer detail, sharper images. Second, resolution. Our sonar can tell us the location of an object down to a few centimeters. Not bad, until you hear that dolphins can distinguish differences down to a few millimeters. That's the difference between spotting something round and knowing instantly whether it's a ping pong ball or a golf ball. Third, processing speed. Machines take time to digitize and calculate echoes. Dolphins? Their brains do it instantly, no lag, no buffering. Imagine if your Wi-Fi worked that fast. And finally, adaptability. Human sonar is pre-programmed. Dolphins, on the other hand, can tweak their clicks, change intensity, and adjust to any situation on the fly. So if a dolphin and a submarine had a race to find a tiny fish in the deep sea, who wins? Every single time, it's the dolphin. So theory is great, but what does dolphin sonar look like in action? Picture this. A muddy river where visibility is basically zero. No diver, no camera, no machine could see a thing. But dolphins? They cut through that murk as if the water were crystal clear, hunting fish with surgical precision. Or think about open ocean rescues. There are countless stories of dolphins guiding lost swimmers back to shore. Was it curiosity, compassion, or just their sonar telling them a human was in trouble? Maybe all three. But what's clear is that their navigation doesn't just help them survive, it sometimes saves lives. And here's one of the most fascinating examples. Military-trained dolphins. Yes, you heard that right. The US Navy has worked with dolphins for decades to detect underwater mines, tiny objects that could destroy a ship. Why use dolphins instead of high-tech machines? Because their sonar is so sensitive, they can pick out a buried mine in a cluttered seafloor where human sonar just gives fuzzy noise. So here's the million-dollar question. If dolphins have been doing this for millions of years, why can't our technology keep up? The short answer, biology is still light years ahead of engineering. Think about it. A dolphin's sonar isn't just about sending clicks and getting echoes back. It's about a living brain processing those echoes instantly, adapting in real time and merging that sound map with memory, teamwork, and decision-making. A machine can measure, sure, but can it improvise? Not even close. Engineers have spent decades trying to mimic dolphin sonar, from naval sonar arrays to medical ultrasound machines. And while we've made progress, we're still chasing them. Why? Because dolphins combine hardware and software in a way no engineer can replicate. Their melon and jaw act like custom-built instruments, while their brain works as the world's fastest supercomputer. And here's the exciting part. Scientists are actively studying dolphins to inspire new breakthroughs. Imagine rescue robots that navigate disaster zones like dolphins do, or medical scanners so precise they can spot problems early, just by echo. So the big takeaway is this. Our best tech is impressive, but nature's design still wins. So, what have we learned? Dolphins aren't just smart, they're carrying the ocean's most advanced natural navigation system, one so precise and adaptable that even our billion-dollar technology still struggles to keep up. From hunting in muddy waters to saving human lives, their sonar isn't just survival, it's superpower. And now, here's where you come in. If you loved diving into the science of dolphin sonar, make sure you hit that subscribe button for more wild science every single week. And I want to know, what animal superpower should we break down next? Drop your wildest ideas in the comments, because your suggestion could be our next episode. Thanks for watching, and I'll see you in the next video.